Hi everyone, in this video we will see how to develop a project of automatic hand sanitizer dispenser. This project is a touchless automatic hand sanitizer dispenser built using Arduino Ultrasonic Sensor and Servo Motor. The system detects a hand placed near the dispenser without any physical contact. When the hand is detected within a specific distance, the Arduino activates a motor that presses the sanitizer pump automatically. This touch-free mechanism maintains a hygienic condition by preventing the spread of virus and bacteria through shared surfaces. So this project is a very inexpensive, user-friendly and suitable for public places like school, hospital, office and shops. These are the components required. We need Arduino Uno board, ultrasonic sensor, servo motor and jumper wire. It's a circuit connection diagram. Ultrasonic sensor has 4 pins: VCC, ground, trigger and echo pin. The VCC pin is connected to 5 voltage of Arduino Uno board. A ground pin is connected to ground of Arduino Uno board, and the trigger pin is connected to a 10th pin of Arduino Uno board. Echo pin is connected to 11th pin of Arduino Uno board. And also you can see the servo motor has 3 terminals, VCC, ground and signal pin. And the signal pin is connected to 9th pin of Arduino Uno board, and VCC is connected to 5 voltage of Arduino Uno board, and ground of servo motor is connected to ground of Arduino Uno board. We will see how to write the syntax for automatic sanitizer dispenser. Here I am using a servo header file. So I am using servo my servo, which means you are going to create the servo object to control the servo motor. So before moving the servo motor into different positions or different angles, you have to initialize the position. So I am using int position is equal to 0. This is actually the variable to store the servo position. After which you need to define the pin connections. The servo motor is connected to, the servo motor signal pin is connected to 9th pin of Arduino board, and trigger pin is connected to 10th of Arduino board, and echo pin is connected to 11th of Arduino board. Next you need to define the variables. I am going to measure the distance, so I am going to use long data type for duration. Then you can use int distance. You can use a void setup loop. In this we are going to declare this input output. So trigger pin is used as an output pin, echo pin is used as an input pin, and my servo.attach, you are going to attach a servo on pin number 9 to the servo object, and my servo.write in the write 0 in the sense you are going to set the servo to initially 0 degree. Then you can use serial.begin, where you will be going to start the serial communication process. Next you can use void loop. In this you are going to set the trigger pin as made high for certain time period and low for certain time period. So here the digital write trigger pin I made as a low, then 2 seconds delay is created. Then I can make the digital pin trigger pin as high and given delay of microseconds 10. Then you can make the trigger pin as low. So here the time taken to return the signal back to the receiver pin we are calculating in terms of distance. So here you can use the duration is equal to pulse in function. Echo pin is made high, which means the echo pin is ready for receiving the signal reflected back to the receiver. Then we can calculate the distance. The distance is equal to duration into 0.034 divided by 2. This is the speed of sound in air. Then you can print the distance in the serial monitor. So I can use a syntax serial.print, and you can give it in quotes distance so that you can print the distance value. If you want to print the distance in new line, continuously want to measure the distance and you want to print it in new line, we can use a syntax called serial.println. Then if the distance is less than 10, the servo motor is starts rotate. So here you can write the syntax my servo.write, which means the servo motor initially rotated 45 degree. After a certain delay, then it rotates to 90 degree. After a delay, it rotates to 135 degree. Then after a delay, it rotates to 180 degree. After reached 180 degree, you can bring the servo motor at 0 position, then give a delay, then close the program. So I already explained the circuit connection. Now straight away we will see how to simulate the circuit and see how the circuit behaves. Press start simulation, and this is a code. So here the code written is, if the distance is less than 10 cm, then only the servo motor can rotate at 45, 90, 135 and maximum of 180 degree. Then the servo motor bring back to original position of 0 degree. Now we can see the serial monitor. So in the serial monitor I am going to print the distance value. Here the distance is 8.2 cm and it is printing approximately 8 cm in the serial monitor. Now we can just simply move the ball more than 10 cm, and you see that the servo motor does not rotate. When it goes less than 10 cm, then only the servo motor can rotate from 45 to maximum of 180 degree. Now you can closely observe the ball movement. The ball is moving at 111 centimeter, and there is no rotation happens in the servo motor. When the ball is very close, less than 10 centimeter, then only you can see the servo motor is rotates.